Hello guys and welcome to part 3 of the series Processing in BlueJ. In this series, we use the processing library in BlueJ to add a bit of graphics to our Java program. And in this video, we are going to create this. This is rain. But before we're going to create that, let's recap what we did in part 1 and part 2. In part 1 of our series, we downloaded and set up BlueJ and processing. So if you haven't watched it, watch that. And in part 2, we got used to the basics of the processing and BlueJ and made a simple fruit collector game. So the links will be in the description. You can go and watch. In this video, we are going to make the rain, but what we are going to learn along with that is number 1, Deltatime. It's a very basic concept in game developing. So we're going to learn that. And number 2 is Parallax effect. So as you can see in the video, that the rain, there are some drops in front of you, they are close to you, and some drops far back, and you can see a bit of 3D kind of effect, but although it's a 2D camera, as you know. So to achieve that effect, we are going to learn the parallax effect. And number 3, we are going to learn a little bit of trigonometry, a very basic little bit of trigonometry, sine cos, to achieve the tilt in the rain that you can see in the video. So that's the 3 things that we're going to learn in this video. So let's get started.
First, we will create a class called rain, and then we'll open it and also open the demo sketch which we made in the first video, right? So we need to import processing.core. If you haven't watched my previous 2 videos, it should be a bit difficult for you, so please watch those videos. Okay, and we need to create a object of our class and run it, right? So we'll go there and we'll do that, and our class is called rain, so let's rename it to art. And you can see there's an error there because we need to extend the p-applet class, and we need a settings method. This settings method will tell us it will tell the program what should be the width and height of the window. So let's check it once. It should run, and yes, a window is opening. So we'll now open the code again and we'll go here. This is a setup method which will be run once when our project starts, and the draw method which will be called on every frame, right? So the background is green for now. I'll not change that, and I'll remove all that. Okay, I'll introduce to one method called line method which we will use to draw the rain. If you don't know what line method takes, are 2 points and x and y coordinate for each point, so it will take 4 float variables. So let's say I want to draw a line from 100x 80y. These are the coordinates of the first point. So from that to, let's say, 500x and 400, or let's say 600y, right? 600y, let's reduce it to 550y. So let's check it. So this is 100x 80y and 500x 550y, right? So this line method we will use to draw our raindrops. Now we would change the line color to 255, which corresponds to the white color. And before writing the code, what we will do is we will create a class for raindrop which will help us manage multiple raindrops, because we want to create a lot of raindrops. So for that, if we create a class, that would be more manageable, more readable, and more debuggable also. So we need an x variable for our x coordinate, y variable for our y coordinate, the length of the raindrop, the velocity, the thickness, right? And we'll create a constructor, and we'll take the x and y for now, and we'll say that this dot x equals to x, this dot y equals y. Length should be, let's say, 10 for now. Velocity equals some 40 for now, and thickness equals 3 for now. and we have to create a draw method in which we will draw the raindrop, right? And we'll say that this dot y. So initially what we'll do is that the raindrop will come down vertically, 90 degrees vertically. There will be no tilt. So for that only the y will change, the x will not change. So let's say that the y equals to velocity into some time. We need that it change up to some time. So here we need to use delta time. But for now, let's say we will keep it simple. We'll just copy what I write, 0.166f. Now if you're curious how I'm getting this number, just go to the calculator, type 1 divided by 60, because my computer generally runs at 60 fps. This program generally runs on my computer at 60 fps. Now if you don't understand why I am doing this and what I am doing, no worries, in some time I'll explain the delta time just a few minutes later, so don't worry. So for now, this is how the y is changing, the y is increasing, and the length, where we will use the length. Before we will using the length, we need to set the thickness. This method, stroke weight, is used to set the border or the line thickness of the anything we are drawing. So we are drawing a line, so this will change the thickness of the line, and then we will call that method. For the first argument we'll put x, for the second argument we'll put y, for the third argument again we'll put x, because the x would remain same for our raindrop, but our y would change. Our y would become y plus length, right? So we are drawing a line from xy to xy plus length. This is how we are drawing the raindrop. So let's create a simple raindrop rd. We will create a raindrop here, new raindrop. Let's create it at the center of the screen, at the top center. So for center it should be width by 2, and for top the y should be 0, right? And on draw we will just call rd.draw for now, and it should work. So let's call it, and let's see. As you can see, one singular raindrop falling. So what I will do is that I will increase the length to 20, and instead of one raindrop, let's create an array of drops. Lot of drops, right? Drops equals to new raindrop array of, let's say, 100 drops, and then for each, for int I equals 0, I is less than instead of 100 I'll put drops.length. So later when I'll change the length, I don't need to change this. I plus plus, it will be drops. Each drop should be a new raindrop, and instead of this I'll say random width and random height. Right, and instead of rd.draw, I'll copy and paste this array here, and I call drops I.draw. Now this should run perfectly fine. As you can see, it's very boring, but it's working. Now one thing is that once the drops go below the screen, they disappear. So what we want is that once they go below the screen, we want them to reappear, right? So for that we'll say is that we'll do a check. If drops I dot y is more than the height of the screen, so we need to reset the position. So the random width, and instead of random height I'll just say -10, because initially we need the raindrops to fulfill the screen, to populate the entire screen, but once it goes below the screen we just need it to reappear on the top. So for that I think it should fix that very simply, and as you can see the full screen is populated, but it's very boring even now. So let's introduce some variation. So a very simple way of that should be to use the random. So we'll say the length is a random variable from 10 to 22. So this is a random variable from 0 to 10. So 0 to 10 a random plus 12, so this would give us a random range from 12 to 22. Similarly, the velocity should be a random from 40 to 140, so it's 40 to 140. And thickness, let's keep it simple for now, and let's call this now. As you can see, there is some variation, so it looks good, right? But there's still a lot of way to go. Before going any further, now let's introduce the concept of delta time. What is it and why do we need that? So for this, I'll go to the copy, so let's go there.
So delta time, what is it? Let's say we have 2 frames. So let's say we are transitioning from one frame to another. So we want to find out how much time is passed between these 2 frames. Now if a game runs in 30 frames per second, that means in 1 second 30 frames are drawn. So for the time between 2 frames would be 1 by 30. It would be somewhere around 0.0333. But the game does not run, or any program does not run at a constant frame per second. Sometimes it's 32, sometimes it's 35 or 28, or let's say your PC is very good, so it's running at 60 or 120 FPS. So we cannot use a constant, right? We need a variable delta time. So for that we need to calculate delta time. And you might say, why we need the delta time? What is the requirement for it? So let's say we have a variable of speed in our canvas. There is an object which is going towards a certain direction at a certain speed. We know the direction, we know the speed. So we need to now calculate that how much distance that object will move in one frame. We know we have the speed, the distance is equal to speed into time. So here we need the time, and for these calculation, and not only in this case but many cases we need the time. So for that we need to calculate the delta time. How do we calculate this? Okay, so we create a variable. In this we store the time of the last frame. So let's say in this frame we store a time, some milliseconds, let's say 300 milliseconds. This is the time. And in the next frame we use the method given in processing to get the current time. Let's say this method and this frame, the time is 312 milliseconds. Now what we'll do is we'll subtract this from this. So we'll do is new time minus last time, and this difference gives us the delta time, right? So new time means the time in the new frame minus the time in the last frame, that is the delta time. And this new time we will store in another variable, will store in the last time, so we can calculate the delta time in the next frame.
Okay, so we'll introduce the delta time now. For this, first we need a variable called int last time, which will store the last time, as it says of last time equals to millis. This is a method in processing which will give us the current time in milliseconds. And again, in the draw method we need to create a variable called int new time, which is the current time, which we will again get using the millis, and we'll say that the delta time, in short dt, equals to new time minus the last time. This should be minus, right? But one problem is that this gives us the answer in milliseconds, which won't be any problem if we use that, but it's a bit inconvenient, so we will convert it into seconds. So converting millisecond to seconds is very easy. Just divide it by 1000 and put an f here, because this is integer, and if we don't put an f here and this is also an integer, the decimal part will vanish. So for that we'll need this f. And now we will say last time equals to new time, because we want this time to be saved as last time, so we can calculate the delta time for the next frame. Now this dt we will have to use here. Instead of this we need to put this dt, but if I compile it, we'll get an error. So we need the dt here, and we need to pass the dt here. So we got that. So there should not be, you cannot see any visible change, but we are now using the Deltatime, which is more appropriate. Now we will introduce the parallax effect. So let's go to the copy once again.
Okay, so in this effect, the things that are closer to you moves faster and the things that are farther away from you move slower. So length, thickness and velocity, these are the three variables that we would vary. We create a variable z. 1 means it's closest to us, closest to the screen, and 0 means it's farthest away from the screen. If it's 0, the length would be a minimum value. So length would be a minimum value. We will decide what value it should be appropriate to our program. And here it will be a maximum value. Let's say if it's here it's 10 pixel, now here it will be 30 pixel. For thickness we would do the same, and same the velocity. If it's like 10 or 20 something, then it would become 40 or 45 or whatever would be appropriate, right? And the drops which are closest to us, they will be bigger and they will move faster, and the drops which are further away from us, there will be very small drops and they will move slower. So this would give us a parallax effect. So let's try this now.
Now to introduce the parallax effect, what we will create is a z coordinate, right? And we will say that if the z is 0, so we will use a range from 0 to 1. If it's 0, it's the farthest from us, and if it's 1, it's closest to us. So z 0 equals furthest, 1 equals nearest. That's what we will call. And here we will say it's a random from 0 to 1, so just write random 1. So this will give us a random variable from 0 to 1, and again here also. And now we need to use this z variable to change these things. So if we think logically, the nearest something to us is, it should be largest and more it should be larger and more faster, and it's the furthest it should be slower and smaller. So the method we will use here to create that is called lerp. What lerp does is that, let's say I have two variables a and b and a variable called fraction. If this fraction is 0, it will return us a. If the fraction is 1, it will return us the b. But if it's in between, it will return us a variable between a and b. If it's 0.5, it will return us the average of a and b, and so and so. So we'll put the z here, and at the furthest our length should be the smallest, so let's say 10, and at the nearest our length should be the largest, so let's say 30. These variables I am using because I have already made this program and I think this looks good. But if you want to change it, you can put anything there, just make sure that this is smaller and this is larger. And then we'll do this for the velocity also. We'll say that the farthest velocity should be 100. I am making it a lot more faster, and the nearest should be 200. And thickness, the farthest should be very small, 1, and the nearest should be 3. So let's now call it and let's see what happens. As you can see, the parallax effect is getting good. Okay, but one thing is that, okay, let me increase the number of drops from 100 to, let's say 300, or let's say 200, and you can see the rain, right? But now are we finished? No. One thing we need is the tilt. For the tilt we need a bit of trigonometry. So let's go to the copy once again, and for the last time, to understand a little bit of trigonometry.
So what we are doing is, this is our canvas, and we are using 2 points, or the coordinates of 2 points, to calculate how our raindrop will be drawn, right? So for the first point, this is our x1, this is our y1, and for the second point, this is our x2 and this is our y2. We can see that our x2 is nothing but our x1, both are equal, right? But our y2 is equal to y1 plus the length. I'm writing alien, so it's basically the length. So this is how we are getting the x2 and y2, and we are calling the method in processing to draw the drop. But now when we are going to tilt the drop, we are going to have to see that this point is going to be our x1 and y1, this point is going to be x2, which is x1 plus certain distance. So our x2 is basically x1 plus something, and our y2 is also y1 plus a bit of something. Now here we see that our y1 equals to y1 plus length, but here it's not length. The length is a little bit larger. If we move this, if we straighten this, we can see that the length will become a bit larger, but we don't want that. We want this portion, right? So I have drawn this diagram. So this is our length. This is what we want to calculate, this, and this is what we want to calculate, this angle. We call it the tilt angle, or how much the raindrop is tilted. Now according to trigonometry, basic trigonometry, the side that we want to calculate that is adjacent or touching to the angle is cos theta. We multiply it by cos theta. So we take our length and we multiply it by cos theta. So here it is length into cos theta. And the side which is opposite to the angle, we multiply it by sin theta. So it's length into sin theta. So our x1 is x2 plus this one. So this one is length. I'm using length because I use length here, into sin theta. So this we have to calculate using some maths method. And our y1, which is this, is length into cos theta. So it's length into cos theta.
Now what we will do is that we will introduce a variable called tilt, which will store the angle, and I will not make it dependent on z or something or a random. I'll just set it a constant, and let's say the angle is 15 degrees, right? This should be okay, but the thing is that in processing all the angles are in radians, but the 15 degree is in degrees, right? So either we need to calculate what should be it in radians, or we just call the method called radians and it would do the calculation for us. And here what we need is that we don't need to change the x only, we also need to change the y. So I mean we are changing the y only, but we need to change the x also. So initially I would just copy this here, and as I have explained in the copy, in x here we need the sine of tilt times, and in y we need the cos of tilt, right? I might not have explained for the speed, I just might have explained for the length, but it applies for the speed also. And for the length here we also need this, so same goes here. It's x, y and x plus length dot y plus length, but now we need to multiply the sine here, right, and the cos here. Okay, I'm sorry, it should be like this, right? So it's xy, x plus sine tilt times length and y plus cos tilt times length, and that should be all, I guess. I hope if I did not make any mistake, right? This is all. But you can notice, I think if you can notice a problem here is that this space is becoming empty. That's because we are spawning raindrops from the 0 to width, right? And as there is a tilt, so all the raindrops are going like this, so this space is becoming empty. So a very simple fix for that is, instead of spawning from 0, we will spawn from something, let's say negative minus 150. So what we simply need to do is that we will increase 150 here and decrease 150 back here. So this will give us a range from minus 150 to width. If you are not sure how it happens, so simply get that if I just write random width, it will give me a random variable from 0 to 600, or our width is 800, so 0 to 800. But if I write random width plus 150, it would give me a variable from 0 to 950. And now again if I write this minus 150, so this would also decrease by 150 and this would also decrease by 150. So instead of 0 to 800, now I am getting minus 150 to 800. So that's the logic behind this. And since I am doing it here, I also no need to do it down here. So just paste it here and I'll paste it there and I'll call it here. And as you can see, the problem is fixed. Now let's change the background color, right? So let me put this you can change the color to your choice. That's the thing that I am trying to say. Okay, this should be okay. right? Now let's increase the number of rain drops. Let's say instead of 200, let's say 350. Now one thing you will see that okay, it's a bit there's a bit of jitter. I don't know if you can see or not, but an easy fix for that is just increase the speed. So instead of 100, let's say 150 and 280. So I think the jitter should be gone by now, right? It's still there, but I don't think it's too much problematic. One problem is that you can see there are a lot of raindrops in front of you and a little less raindrops behind. So to fix that, this is not necessary, but this is a preference you can do, is that you can set z to z times z. You can just make it z square, and that would put more of the raindrops behind. As you can see, more raindrops are now behind and lesser in front, but the jiggle is a lot. I think we can just reduce the number and it will be fine. Okay, there's a lot of raindrops, I guess. And this should be okay, right? So this is the rain. This might not be visually very appealing for you, but get this, that you have learned a lot of things in this video, and you can apply this to create more interesting things. So that is the premise of the video. We would create more interesting things and more appealing things in the coming videos, so subscribe and stay tuned for that.
You might notice that I made this video after 2 years. That's because I got a few comments on my recent videos. I mean, not recent, yeah, on the older videos, and that really motivated me to make more videos. Yeah, so please, yeah, comment more, do more comments. That would really motivate me to make more videos, and I hopefully will make more videos in this topic, in this series, and I'll think of new more videos to make, right? So that will be all. Thanks for watching.